Welcome, and today we're going to be working with the vertex form of a parabola or a quadratic equation. And what we're going to try to do today is we're going to show you how to find the vertex and how to find points so that you can eventually graph this. Now we'll be using the order of operations list of order of operations to help us do this process. So the first thing I want you to know is whenever you're trying to find the vertex in this form, the easiest way for you to think about it is what value of x makes the inside of that 0? Well, what minus 8 is 0? 8 minus 8 is 0. So we're going to replace the x with 8 and solve for y. So the vertex is going to be 8 comma something, whatever that something is. Now 8 minus 8 we know is 0. And order of operations says we have to do the parentheses before we do the power. Next thing is 0 to the second power. Well, I hope you know that's 0. And then we do the adding and subtracting, and we find 0 plus 4 is 4. Now you may have already figured out when it's in this form, when this becomes 0, that whole thing is 0, so whatever this is being added or subtracted with it is going to be your y value or your vertex. Even if there's often a number out here multiplied times the parenthesis, even if that's the case, if this is 0, 0 times anything is 0, so whatever's added or subtracted is going to be your answer. If it's plus 4, it's 4. If it's minus 4, it's minus or negative 4 here. All right, now we're going to find some points. Now we already know from the previous slide that 8, 4 is our vertex. I'm just going to put a little v there to remind me that that's my vertex. So what I want to do next is I want to find at least 2 points on either side of that vertex. So what I would usually do is I would go from this x value on the vertex, I would go up 2 and down 2 from that value. So 8 plus 1 would be 9, plus 2 would be 10. 8 minus 1 is 7, minus 2 is 6. And those are the values I'm going to substitute in for x to solve for y. So as I go through this, I'm going to take this, and now you're going to see on your worksheet the original problem, and then you're going to see several problems where they actually give you something like 9 in there, and they ask, basically what we want you to do is simplify that and just practice your order of operations first. And then eventually we're going to give you problems where you have to do all of the work. But in this case, 9 minus 8, 1 squared, and you just proceed through it. So if you wrote this out and just left that blank, you could keep reusing that or write it out each time. Y, 1 squared is 1 plus 4, and 1 plus 4 is 5. So I can come over here and say that for 9, y is 5, and that's a point, the 0.95, often written like this. All right, so now we're going to continue to find the other values. So I'm just going to erase this and go to my next one. Now, here's what's interesting. If you have the correct vertex, when you go on either side of that the same distance, like up 1, down 1, it should come out to the same y value, because that's what the graph of a parabola looks like. It either goes like this up or it does this down. And so you get, you know, values that are the same y but different x values. So let us see what happens when we plug 7 in. 7 minus 8, we have to do that first. 7 minus 8 is -1. So I write the whole thing out. And then I square -1. Now when you square where the negative is on the inside, that means -1 times -1. Well, what's a negative times a negative? A positive. 1 times 1 is 1, plus 4. What's 1 plus 4? 5. Same answer. So once you can see that that works, you should notice that 10 and 6 should have the same result. We're going to test it just to be sure, but 10 minus 8, 2. 2 squared is 4, and 4 plus 4 is 8. There's my y value for 10. I'm going to go back through. Now, I'm actually going to do a little less erasing here. I'm just going to erase here and here, just for now, just so that I don't have to write it as much, just so you'll see what I'm talking about. 6. 6 minus 8. -2. What's -2 squared? Not -4. +4 plus 4 is 8. 8 again. What do you think? Now I've got my vertex and 2 points on either side of it. That's 5 points, and that's what I want to see a minimum of anytime we graph with a parabola is 5 points, the vertex and 2 on either side. Sometimes there's way more than enough points that you could put there. You could put, 7, 9, 11 points in one graph. Other times you can only fit a few points, hopefully 5, to show your graph for a parabola. Let's try another example, because otherwise they don't fit on the graph. All right, let's look at this one. Now this one looks a little tricky. -1/4. All right, let's just start us off without getting too hooked on the -1/4 part. What value of x makes this 0? Hopefully you said -3. The opposite of this is -3. -3 plus 3, 0. If this is 0, then this is 0, which makes this 0. The whole thing, that whole part. So 0 plus 2 is 2. There's my vertex. Let us try a value above and below. So, for example, if I went up 1, that's -2. If I went down 1, -4. Now those should come out to the same value. Let's try it. -2 plus 3. 1. All right. What's 1 squared? 1. All right, now, order of operations tells me I have to multiply before I add, right? So I end up, -1/4 plus 2. Well, that's not going to come out very nice. It's going to, well, I have to take a 1/4 away from 2. So if I had $2 and took a quarter away, I'd have $1.75 or 1 3/4. Okay. That's not really the point that's going to be easy to graph. So that's not really what I want. Let's still do -4 just to prove that it comes out the same. But then I'm going to show you something else. -4. -4 plus 3. Signs are different, so keep the sign of the larger and subtract. -1. -1/4. -1 squared is 1. Again, we're going to get -1/4 times 1 is -1/4 plus 2 gives us again 1 3/4. Now that is going to be more difficult to graph. Let's see what we can do to make this better. Let's go out a little further here. What if we did -1 and -5? Well, -1 plus 3, that makes the inside of this even, which we know is going to work somewhat better. But even more importantly, it's going to make this something, once I square it, that makes that a 4, which is divisible by 4. 2 squared is 4. And when I multiply -1/4 times 4, remember you can put that over 1, the 4's can reduce, and I end up with y equals -1 plus 2, or 1. My suggestion, anytime you have a fraction out in front of the parenthesis, is that you try to come up with a value of x after you found the vertex. Find a value of x that started going up and then go down. That is going to make the inside something that's going to be divisible with the 4, or the denominator. And in this case, it turned out if it's even 2, 4, 6, then when you square it, it ends up as 4 and makes it very easy to work with. -5, let's give that a shot. -5 plus 3, that's -2. -2 squared is 4. And like we saw a few minutes ago, these will reduce. We end up with y equals -1 plus 2, or 1. All right, so what have we learned? We've learned that if you only go 1 when 4 is the denominator, it's not enough, and you're going to get fractional answers. If we go 2 from the vertex in either direction, we come up with a nice result. So let's go 2 more from -1. So -3 plus 4 would be +1, or 2 from -2 more away from -1 is +1, and 2 further down is -7. Let's see if those not only come out to the same value, but also come out to a nice answer. 1 plus 3 is 4. 4 squared is 16, because we have to do power before we do multiply. Reduce the 4 with the 16, and you get -4 plus 2, which is going to come out to -2. A nice answer. If we plug in -7, we should also come out to -2. Negative 7 plus 3 is negative 4. Negative 4 squared is positive 16. Put it over 1, reduce. I get negative 4 plus 2, negative 2. Now I have definitely 5 points. I actually have 7 points here, but 5 that are going to be easy to graph for me to do my work. All right. Let's try this one. In fact, I'd like you to try this one on your own. First, find the vertex. So pause the video, find the vertex. Once you've found the vertex, then unpause, check to see if you're right, and then go ahead and pause it again and find 2 points on either side of the vertex and see how you did by unpausing the video. Now that you've done the vertex, you should have found that if you put positive 3 in, that you will get positive 2 out. Negative 3 minus 3 is 0 squared. Negative 2, 0 squared is 0. Negative 2 times 0 is 0, plus 2 is 2. And there we have it. Now pause and try to get 2 points on either side of your vertex. Minus 3 is 1. 1 squared is 1. Negative 2 times 1 is negative 2, which gives me